homework, so I will answer this question later on. Yeah. And originally, I was assigned by this guy to yesterday morning, but he kicked me out. So, I'm not talking in this session. Yeah. So before I can answer this question, or maybe I tell you a little bit about what I'm doing in Warwick and in Fudan University. So we are a group basically really working on experiment. So I have a team, experiment team working on experiment, and I will tell you a bit about what's reconstruction and working on theory as well. So I tell you my background, what we are doing at the moment, and then try to answer that homework, later on. Okay. So that's what we are doing. From experiment side, actually, we are a team, as I mentioned yesterday, we do collect a lot of data ourselves. So we spend a lot of money, a lot of efforts to collect the data from genetics, brain image up to behavior. And then we do, develop a lot of machine learning approach to deal with all data. And this is actually my publication from last year. And I'm on the driving seat, if you want to tell, I'm really the senior author for possibly half of the publication, more than half, I think, So we really work on biology from experiment side and very closely. While myself, I'm a biologist as well, in a sense. So that's from experiment. We do experiment from very, very basic biology issues. And then so look into all these mental disorder from schizophrenia, depression, and autism, AD, etc. And so from experiment, from learning biology, and based on biology knowledge, so what we did for the past few years, starting from a few years back, and what we try to do is we want to build a digital twin for the brain. So that's the thing I spent a lot of time in the past few years. So we try to set up, so we have 86 billion neurons in our brain, so huge, and we have 100 T parameter, 100 trillion parameter to be estimated to construct this model. So based on the data, so we spend quite a few years on it, and actually we use one of the largest computer during the time, so we use 10,000 GPUs, try to reconstruct this model. And at the moment, that's what we have actually, so as I mentioned, for digital twin model, we have to find these 100 trillion parameters. It's a connection between 86 million neurons. So that's possibly the largest model at the moment in the world. Possibly, as you know, ChatGPT-4 possibly have 1 trillion parameters to be estimated. So how can we do it? It's a funny thing, we're using data assimilation, essentially common field approach. So we estimate all these parameters, and that's what we did already, with fMRI data and with MEG data as well, and for zebrafish as well, and we are working on these two models. So we try to build a digital twin for the brain. And if you think about the mathematics or applied mathematics, the most successful mathematical approach or branch is fluid dynamics. I would say, computational mathematics. So that's what we are doing for the past few years. We want to analyze data, understanding biology, and then come back to math or statistics or probability, try to build the model there. Well, the theory part, maybe I skip it. We try to build stochastic computation rather than deterministic computation for the brain at the moment. So that's my homework. So I start the answer. Yeah, I just give you a basic background of what we are doing in Fudan and Warwick there. And so the next stage for the next 5 or 10 years is the first question. To me, I think, as a applied mathematician or statistician, or maybe more probabilities. Yeah. So for me, what we try to do at the moment, I think, in the next 10 years, if we can build a virtual you, that will be my dream. Okay? So using mathematical approach, use a statistical approach. So as I mentioned, for example, we try to build a digital twin brain at the moment, and so use all this data we have, and we estimate this is 100 trillion parameters there. And so if we can have a brain and a body of virtual you, then we can do a lot there. Yeah, so that's my dream. That's my blue sky dream for the next 5 to 10 years, okay? So all this model, of course, based on biology fact and first principle, we have to estimate a huge number of parameters there. How can we develop a statistical approach or mathematical approach to reverse engineering to estimate all these parameters? I think that's a huge task. And some of Hongtu's stuff, for example, he tried to link a brain with body, with heart. All these things, might be help us for our purpose, I think. So that's my dream. And if we have this virtual you, I think we can change a lot in our area. For example, we can. That's one of the things we are doing. For example, we try to using our virtual brain to test all this brain-machine interface. Yeah, so if we put one electrode in your brain, what happens essentially? Yeah, like a DBS, for example, some of you will talk about. So that's why I will never allow anyone put the electrode into my brain. Yeah, but that's my digital twin brain, so I can put whatever you want there. Yeah, to test what's going on. And for example, another thing, for example, we can use for say drug experiment, for example, for the data there, we can manipulate the digital twin brain and see what's going on there. And so I hope we can really change the practice in brain science, for example, or brain disease, rather than doing all these wet experiments. We can do the dry experiment rather than carry out all these. And the most important question, open question to me, I think I mentioned to Martin yesterday as well. So one of the things I think in AI or in all this model or in my model that I haven't figured out another thing I want to do next. How can you implement a biologically realistic learning loop there? At the moment, AI is basically BP, which is too trivial to everyone sitting here. Yeah, I did have an argument with Jeff Hinton, So I told him that's, first year undergraduate students, we can do it in math department. Yeah. So how to implement this really biological learning rule from our model or from biology, and then we can go back to AI, say, implement this learning rule in AI system. And we can go beyond the current AI, maybe go to a little bit of AGI, general AI. So that's I think that will be one of the very important questions for we say people sitting here from statistics or from AI side. So that's my 3 questions. And the final question you guys want me to ask, to answer, I think I should. So I put a little bit of Chinese here for you guys. I know that we don't have many foreigners here, but I already summarized what's going on in our Chinese video there. Yeah, so I can say, can you hear me? Oh, sorry, is that a sound available? No, not now. I recorded it. Of course, it's 1 or 2 years back. I think we have a ceremony for our, alumni forum. The first one in statistics, actually, back to Peking University. Can you? I'm sorry, I should ask you a bit earlier. Do
we have sound?
No, I don't hear anything there. Is that sound? Oh. No? none of this. Well, I should check this earlier on, but sorry for it. But, a little bit, okay, yeah. In Chinese or in English? Well, we have a first alumni forum in statistics, and they invited 3 of us back to Peking University, Samuel Kuo, and Liu Jun, and myself, 3 of us, talking about in the first forum about statistics. I think it fits this conference very well, and the conclusion is that we have to work problem-driven in statistics rather than say publish a method only for method. So so that's a key thing. They ask about what we should do in statistics to accelerate all this progress. And this guy come up say he want to do real data. So if he can be in China, he will visit me more often. Into Shanghai. So that's the message I want to give. Yeah.
非常引人入胜。所以我们稍微时间推后一点，主要是对君和 Sam 在美东那边时间比较晚了，所以我们尽量的这个就是discussion 这个环节，我们想讨论一些，就是说首先可能我大概也这个问了一下，就是比如这边大家感兴趣的一些问题啊，关键性的一些讨论，可能我这边 summarize 一下，然后这个之后可能参会的这个老师和同学，如果有这个包括刚才3位老师讲的这个报告里面的一些学术性的讨论，还有关于这个统计学的一些统计学与数据科学的一些更 general 的这个 discussion。对，其实这个也是推动这次校友学术论坛的一个初衷，就是说我们从这个尤其是国内统计学科在这个现在包括数据科学，包括交叉研究各方面都很需要这个有进一步的这个发展和推动。就在这方面来讲，所以说今天的这个第一期我们这个学术报告也是主题也是集中在这个不光是统计学，包括数据科学，还有这个更跟其他学科领域更广义的这种交叉研究上，在这方面的一些主题报告。所以说也想请这个3位这个我们的杰出校友君 Sam 还有冯老师，这个大家聊一聊，就是说在现在的这个时代背景下，我们统计学 in general 或者是国内的这种统计学科，我们怎么样能够抓住这个时代的机遇，然后推动我们学科的自身的发展，还有和别的学科的一些深度的交叉融合。君还在是吧？
对不起，还行的。
不好意思，这个时间拖的有点晚了。对，就是说这个看3位这个给大家一些这方面的这个前瞻性的一些建议和指导性的这个comments。
我这个先抛砖引玉吧，我觉得很难有真的什么前瞻性，这还是 old wisdom。我是非常欣赏那个冯建峰他们做的那一套东西，我觉得那是正路，就是说真正的投入到这种大问题里边，然后去想办法去做 leaders， 然后真正的去跟这个就是生成数据的这些人多接触吧。虽然咱们不可能所有人都做到建峰这样的哈，但是咱们至少可以做到建峰的队伍里掺和，或者做点搞点数据啊什么的，然后再发展一些理论出来。我觉得这个还是一个比较有影响的一个做法。当然像 Sam 他们也是跟很多这种实验科学家都有非常深刻的接触。我还是觉得我个人当然做 research， 虽然现在有时候理论啊都做点，但是很多的那种 insight 呀和那种问题啊来源还都是非常 实际的问题。所以我决定，我要是再等多回国的话，我肯定要多拍这剑锋的马蹄啊，这个东西，钱是小事，这数据还是比较重要。
来上海，来上海。
Yeah. That's my friend coming to come to Shanghai.
Yeah.
Okay.
Yes. So,
Yeah.
so I want to translate the main takeaway message from the video is we need to become best friend with Jianfeng so that we can get onto his big data wagon and have access to the whatever digital twin or foundation model or all the big data. That's what Jun says.
So I have more like comment. Okay, so that's a great work. So I'm also working on the neuroscience project. What we're doing actually, we're still studying the rats, the episodic memory, how the memory form over the time, and how they remember the things over the time, like use the rats to smell the odor. Yeah. So I want to say something about that. I think what imagine things like why the things we can imagine in the future. So these days we talk about drug discovery, immune system, but for the brain disease, we should think wide. I think if we can understand the lot-of-thing mechanism, then we're able to, let's say, do the device, insert the 3D chip in the brain, especially for Alzheimer's disease. Pretty much there's no cure, right? You cannot reverse Alzheimer's progression. But something more, it's very terrible for a lot of Alzheimer's. Do something medical device, more like science fiction type of things, insert a chip in someone's brain.
One of the advantages for working on the brain science is, we have feedback as well. So we can really look into the future of AI. It's not only we can deal with some of the biological problems. And another thing I always found funny, when I talk to all these people want to solve the AD problem. Impossible. What in my mind is you never think about you will solve this problem, but if I can improve the treatment, for example, by 5%, I have enough, right? Or depression. For example, we do work on a lot on depression and Alzheimer's disease as well. So my belief is, no, you cannot solve it, but if you can improve it by a certain percentage of the treatment of depression, for example, that's enough for me. Right? So I think if people, when they talk about the disease, they always say, we can solve the problem. No, it cannot. Impossible. That's a very complicated issue. If you really look into the data, working with a clinician, working with a biologist, you will realize it's a very, very complicated thing. But I think as an applied mathematician, or statistician, what we can do is maybe we can develop some virtual organ, essentially. That's what we, essentially from applied math, what we are doing here. A lot of, ours is a flight or submarine. So we simulate it first before we really into practice. So that's my dream. We build a kind of a digital twin at the moment and try to put it into real use, real applications. Okay.
Yeah. So before we jump into